Well, Molly had 230 participants on hers the other day. I told her that that's a pretty high bar for us to try to hit, but we'll see.
I saw her stuff and I told her the same thing. I said,
Yeah.
but she's a natural on these kinds of things, man. She ought to be on TV.
Oh man, I tell you, yeah, she's something else.
Hey everybody, those of you that are already on, we're going to just start in a few minutes. We're going to give a couple of minutes to pass by here and then we'll get started. Thanks for joining us tonight. The good looking guy on the top is Rick Williams, and the old guy on the bottom with the long hair is Dave Peterson. So
two old guys, the two old guy meeting.
Yeah, but my hair is getting so long, Rick, that I got it like pinned back and back. I'm going to look like I looked at in college.
Well, it's funny. My wife's cut my hair ever since we got married. So
okay,
if it gets too long for her, and it does before it bothers me, then she cuts it.
Got it. Hey, everybody who's on, I'm going to wait about one more minute here and then we'll get started. Rick and I are probably both drinking out of FFI Yeti mugs, and mine, I swear, has water in it. I can't speak for Rick, so.
One has water in it. And I have my Idaho angler one. So
I gotcha.
There we go.
For those of you watching, Idaho Angler is Rick's Fly Shop. Next time you're in Boise, stop in. I went there last year, and it was probably one of the best fly shops I've ever been in. It's really beautiful.
Thank you. We've worked hard at it.
And I didn't get kicked out of there as I have out of other fly shops, so I thought things went well. Well, listen, everybody, I think it's time to get started. I want to wish everyone a good evening and welcome to another one of Fly Fishers International online Zooms. I'm Dave Peterson, and I'm chair of FFI's Conservation Committee. The gentleman you see above me on your screen, or maybe beside me, depending upon the format your screen is in, is Rick Williams. Tonight's webinar is the third of a series of conservation webinars. We intend to have 5 altogether. We're hosting these meetings with conservation leaders to illustrate the challenges that our fisheries face and the possible solutions to those challenges. This webinar comes to you courtesy of FFI's 12,000 members, and we appreciate them very much. A little housekeeping. Those of you that have questions during the presentation, you'll find a Q&A button at the bottom right of your screen. Click that button. You can write in your question. I will see the question, and at an appropriate time in Rick's presentation, we'll stop him and give him those questions, and he can answer them. A little bit about Rick before we get on. Rick's a fisheries ecologist and research associate at the College of Idaho. His research throughout his career has focused on conservation of native steelhead and redband and cutthroat trout in Western North America. Tonight we're talking about Columbia River salmon recovery issues, and Rick has been active in those issues since 1987, and in fact co-authored a book on the decline of the Columbia River salmon and steelhead in 2006. Most importantly to FFI, Rick is a senior conservation advisor for us and makes important decisions on the conservation actions we take. And we're really pleased to have him with us tonight. Welcome, Rick, and thanks for joining us.
Thanks, Dave. I see some names on the participant list I recognize and others I don't, so welcome all. I have about a 25-minute slide presentation that is a condensed version of one that another fellow, Russ Thoreau, and I have put together. So, and it really talks about, more specifically about Idaho salmon and steelhead, but basically everything that applies to them applies to the Columbia and the Pacific Northwest. So I'm going to start just actually by running through that. I'm going to share my screen here. And Let's see, there we are. We'll get back up to the top here and jump into slideshow mode. Can everybody see that?
Yeah, that's beautiful, Rick.
Okay, so so this is Can Science Inform Recovery of Idaho and Columbia River Salmon and Steelhead? And this is a presentation that myself and Russ Thoreau put together. Russ is a long-term researcher initially for Idaho Fish and Game, and then many years ago transferred over to the Forest Service, where he's the lead Chinook research scientist for the Rocky Mountain Research Station. He's probably the one of two leading experts on Chinook salmon in the country, the other one being Daniel Schindler up at the University of Washington. And Russ and I have been going all over Idaho and the region giving a longer version of this talk for some time now. So we'll jump in. So here's the Columbia Basin. It falls mostly in Oregon, Idaho, Washington, a bit in western Montana, and then it edges down into Utah and Nevada, and actually has a large section up in British Columbia, but we ignore that because Grand Coulee Dam blocks all fish access up there, unfortunately. Historically, it was the most productive salmon habitat in the world, also the most hydro-developed salmon habitat in the world, and that's from our 2006 book, Return to the River. And today's wild fish numbers are about 2% of the historical run size, about 2% wild fish in the river now to what Lewis and Clark saw when they came through. So then there they are, two of my heroes, and I assume many of yours as well. Here's the Columbia River. Most of it is in Oregon and Washington. The Columbia heads up into Washington and then actually loops up into British Columbia and comes back into Montana. But we're going to focus on the Snake River Basin, and that's shown mostly in eastern Washington and Idaho. The rivers you may recognize are the Clearwater and the Salmon. And Lewis, when they came through here fortuitously in early October, they came right down the Clearwater into the Snake and then passed down here right during the peak of the salmon migration. They talk about getting to the confluence of the salmon, the Snake River and the Columbia, being able to see 60 to 80 feet down in the river and seeing just huge shoals of salmon. Of course, the river doesn't look like that today. It's hard to even imagine, but 10 to 16 million salmon annually return to the Columbia River. That's based on work from the Northwest Power and Conservation Council. Some of us think that number may have been as high as 25 or 30 million on the big years. About a quarter to a third of that, 2 to 6 million salmon come back to the Snake River Basin. The Snake River contributes only about 10% of the water flow that comes down the Columbia, but it comes off a larger geographic mass, and it was a hugely productive salmon area. So in fact, it had disproportional importance, both relative to its geographic size and water flow. 55% of the steelhead that came out of the Columbia River came out of the Snake Basin. 45% of the summer Chinook and 39% of the spring Chinook all originated in Idaho. A little bit of lower Washington, but mostly Idaho. So no other fish spawn so high and migrate so far. They're able to adapt to a changing environment, and certainly our environment is changing right now. So these fish and the Idaho Central High Elevation Habitat may be a climate shield protecting these fish in the future if we can get them up to it. Highest in the world at 6,000 plus feet, 800 to 900 mile migration. I'll tell one quick short little story. Years ago, with a friend, I caught a spring Chinook in Riggins, Idaho. It was a hatchery fish, but it was in Memorial Day time, and that fish had traveled 500 to 600 miles upriver. When we filleted it out and put it on the grill, it burst into flame. We had to throw the lid on the grill, and it burst into flame because the oil content was so high, even after it had traveled almost 600 miles. And it shows you the remarkable nutrition that can come from those fish and how the indigenous peoples depended on them. So salmon and steelhead, iconic in the Pacific Northwest, important culturally and economically, nutritionally essential to the native peoples. They developed a whole trade economy just based on salmon, similar to the Ogallala Sioux and the economy they had based on the buffalo in the plains. They're iconic to Pacific Northwest and Idaho. all the way around. You don't have to drive anywhere to see salmon hotels, the Chinook Inn, all these sort of things. And we're losing these fish out of the landscape. They're biologically extraordinary. They start their life in freshwater when the adult female and male lay eggs in the gravels. The fry emerge and then par develop. They stay 1 to 2 years in the river. Then they start to migrate down for their marine life cycle. They spend a period of time in the brackish water because there's physiological changes they have to go through to adapt to salt water. They spend anywhere from 1 to 5 years in the ocean, in the saltwater environment, and then they come back into the freshwater and spawn. It's estimated that they grow astronomically down in the ocean, and they bring back a huge amount of imported nutrients into these systems in Idaho. Most of central Idaho comes off a large basalt plug called the Idaho batholith. The water coming off that is almost sterile. So these fish imported a huge amount of nutrients back into the Idaho central landscape, the Frank Church Wilderness area and so forth. And you can use isotopes and track those, as they've done in rivers up in Alaska. They can track the movement of those nutrients into the nearby vegetation and into the surrounding hillsides as animals and birds and everyone else feed on the salmon. They're remarkable. I spent my career studying. They're remarkable animals in terms of their adaptability. They have high diversity in their morphology. That's their body shape and form. Their plasticity, which is a term scientists use to talk about whether they're adaptable or not. And the more specialized an organism is, often the less adaptable it is. And many of our endangered species are specialists. So the generalists often have the ability to adapt to new and changing environments. They also have great genetic diversity. All of those things give them, when their numbers aren't terribly depressed, a lot of stability, both environmentally and genetically. That translates to resilience, which is the ability to absorb impacts, ecological or environmental impacts, and rebound. They are ecologically essential as keystone species. Keystone species are species whose presence affects the entire ecosystem that they live in, and the salmon certainly do that. Here's another quick look at their life stage. The eyed eggs, here, and then the little fry turning into par, where they get these cryptic colorations, then turning into pre-smolts when they go silver and start to head down the ocean. This is the part of their life stage that occurs in what we call the natal habitat, where they're born. As opposed to their marine habitat life, the smolts are the ones here, and they go down to the estuary, transition into the saltwater, then move out into the ocean as adults, where they grow and feed, migrate all over the Pacific Ocean, return as adults back into freshwater and spawn. That's the marine portion of their life. One of the metrics that we use to measure all this is a thing called an SAR. It's a survival measure, and it's an acronym for smolt to adult return ratio. We're going to talk a lot about that in the rest of the slides. And very simply, it asks how many adults come back from how many smolts go out. And the simplest way to think about it is a female Chinook can lay about 5,000 eggs. But if we look at 100 smolts that are headed out the river, how many of them come back as adults? And the simple answer is you have to have 2 back to replace the male and female that spawned. So 2 is the minimum threshold for just simple survival and maintenance. And we'll play around with those numbers a little more. The Snake River historically had about 1.5 million Chinook in the 1880s. They were already dramatically impacted at that point because we were netting in the lower river, and canning technology had been developed, converting the fishery from a perishable fishery to one that could be canned and then transported all over the country. And the Snake River in 1995 had 1,167 Chinook back. And that's the time when all of the endangered species listings occurred. So 99% decline. How did this happen? Well, the causes are the usual culprits, and we talk about them as the 4 H's. Hydro, the development of the hydroelectric system. Harvest, long-term overharvest of Columbia River stocks. Hatcheries, shifting production to hatcheries, accumulating data that hatchery fish are not as fit as wild fish. And habitat development all through the basin, big time. And there's a 5th H, and that's humans. And of course, so we should probably change that. Here's a slide I put together for a little while. This is a busy one, but it again shows the life cycle. Here's the adults spawning in the gravels up in central Idaho in the Sawtooth Mountains. Eggs are down, eyed eggs come out, the fry develop, parr start to move down the river as pre-smolts, down to the estuary, and there's smolts now, out into the ocean as adults, and the adults come all the way back to spawn. In the meantime, though, however, we put 4 big dams on the Columbia River, and then 4 dams in close proximity in a canyon section of the Snake River, just before it joins the Columbia. These are the Snake River dams. So the Idaho fish have to pass through 8 dams, and that's pretty tough on them. It also decreases the habitat connectivity. The river doesn't flow very much. It's a series of dams and stillwater reservoirs. And these habitats break or weaken the linkages in what we call the chain of habitats through which salmon move during their life cycle. And that creates mortalities. So each dam encountered impacts juvenile salmon and steelhead. We estimate that 76% of the juvenile salmon that pass through the Columbia hydro system die as a result of injury or stress incurred while migrating. So that's a pretty high number. That's from Howard Schaller. Earlier this year, the feds put out a new plan called the Draft Environmental Impact Statement for how they're going to manage Columbia River salmon, and FFI, along with a whole bunch of other NGOs, submitted comments that were critical of that EIS. And I wrote part of those along with Howard Schaller and Margaret Filardo. This is Schaller, one of our best researchers in the basin. This is his data. What's left in the Snake River Basin? Well, we have a dam right here, the Dworshak Dam. It blocks off the North Fork of the Clearwater. Here's the Hells Canyon complex of 3 dams that blocks off all of the Boise, the Jar Bridge, the Owyhee, and the Payette River systems. But nevertheless, we have about 3,000 miles of good to excellent habitat remaining. And we want to look at what are wild Chinook salmon trends in that remaining good habitat. So before the federal agencies, we call them the action agencies, and they're the ones responsible for running the hydro system and developing these recovery or mitigation plans. Right here where my mouse is, this is the Corps of Engineers, Bonneville Power Administration, the Bureau of Reclamation. And together they are the system operations. So they went all around the basin, presenting to the public and collecting input from the public. And here's the graph they showed of Snake River spring Chinook, summer Chinook. This is an evolutionary significant unit. That's the ESA equivalent to a genetic population. And they're showing you how they're doing from 1990 to 2015. And the blue mountains are the wild adults by year. The red is the 4-year running average. And then here's the abundance level. So actually, you know, you look at this and you think, well, things are improving, you know, maybe not really fast, but on the left axis, these are wild adults at Lower Granite Dam, which is the uppermost of the 8 dams by the thousands. So you can see back in 2000, we had about 45,000 fish back, you know, so it looks pretty good. But be careful of what you're shown. Here's a longer time series. We take it back to 1957. This is what you were just shown. So you can see, that's the briefings from 1990 to 2013. And notice they've fallen off again down here. A flat period before and a steep decline before that. So the lesson on here, this is the Idaho Fish and Game data. It goes back to 57. There are data sets down in the lower river that go longer. So be careful of what you're shown. The time series influences how the graphs are interpreted. This is a phenomenon called shifting baselines. It's been well recognized as kind of affecting our thinking within each generation. Biologists come in and they kind of see where the resource is and they see an improvement and they think, well, things are better. But if they don't have a historical understanding, they don't really realize how degraded they've already become. So we have to be kind of on guard for that one. It's a phenomenon that occurs in a lot of natural resource management, not just salmon issues. Let's take this same graph again. Here's the downward trend. But if we look at that, Schaller and Charlie Petrosky reported that there was a 50% harvest on Snake River Basin Chinook in the 50s and 60s. So that's what the actual decline looked like, but this is the number of fish that were counted. So why? Well, it's because of development of dams. Here's the dams, the main stem dams that went in above Bonneville Dam since 1957. So 7 dams went in. These are the Columbia River dams. These are the Snake River dams. Then you can see it all kind of collapse down here. This is where the endangered species listings occurred. This period right in here, there were clamorings for listings, but they decided on a political solution. For those of you who live in the Northwest, this is when they formed the Northwest Power Planning Council through the Northwest Power Act. And its purpose was to try to balance hydro generation and salmon recovery. And they did all that to avoid the listings, but the listings happened anyway. You can see down here about 95, they just really crashed. We have a real high point here. We'll talk about that a little later. And then if we go back even further, that graph, we look back, into the 30s. Now we're going clear back to the 1800s. This is based on harvest, since nobody was actually counting the fish. But so that's why it takes off, because this transition right here is the transition I talked about from salmon being a perishable commodity. The canning technology developed, and so they really harvested them, pulled the run down, harvest a long period of sustained harvest, period of decline. And then here's where the graphs that we looked at from Idaho Fish and Game happened. And the CSRO one was clear out over here. Decline and extinction, dam building period. There's the longer period of sustained harvest. And so this is next comment is from the National Marine Fisheries Service, NOAA, that oversees a lot of the recovery. Evidence suggests the primary cause of Snake River salmon declines is the hydro system. There's the 8 dams. And there's from the National Marine Fisheries Service 2016 draft recovery plan. Federal hydro projects remain the main threat to the viability of Snake River spring and summer Chinook salmon and steelhead. Can't say it plainer. That's coming from the National Marine Fisheries Service. So let's look at SARs and see if we can learn a little bit more. These are some Chinook data. I'm not sure why there's a gap right here. But anyway, there's that 2% maintenance threshold I talked about. There's the 4% SARs. This is the Northwest Power Planning Council's goal for recovery. And here's the NIMS, NOAA. This is the federal government. So they want a 6%. So anything below the red line, the population is declining. So, and anything in kind of this range, well, let's see, what have we got here? These are, okay, so these are data from some of the literature showing that since 1990-75 in Lower Granite Field, the SARs were often below 1%, but in the 60s, prior to the dams being done, they were 3.5% to 6.5%. So probably those populations could have remained stable without any other changes impacting them. But once all the 4 Snake River dams went in, they've then been down below 1%. And from 2000 to 2017, about 0.7%. So that's kind of the maintenance range. That's kind of the rebuilding and recovery range. And we're not doing very well lately. Another way we can look at it is we can look at the Snake River fish that go through 8 dams versus fish that go into the Deschutes, John Day, and Yakima, where they only have to transit 3 dams. And so these split those graphs in. This is the early 50s and 60s. And this is the time sequence those dams went in. So you can see as increasing number of dams went in, these 2 lines diverge. And these are the Snake River fish. So yes, there's been a decline in the downriver stocks over time, but not as significant a decline. So the Snake River fish survive 1/4 to 1/3 as well as the downriver stocks. So here we can look at the SARs by dams. Well, for Chinook, I should point out we don't have any data at dams 5, 6, and 7 because the Snake River dams are in a canyon and there's no tributaries that come in there. So you kind of get fish going into the Yakima, John Day, and then you get everybody else that's going from the Grand Ronde up into the Snake Basin. So Chinook 3.6 in the John Day River, 2000 to 2017, 2.5 in the Yakima, not great, but above threshold, and then 0.7 in the Snake River. And here's the Steelhead SARs. They're a little more resilient fish, but you can see again, Deschutes, John Day, Yakima. So 2, 3, and 4 dams up, and then 8 dams below maintenance threshold. So, and then here's just another look at the wild steelhead SARs over time. And the dams again went in, the Snake River dams went in right in here. The last one went in 75. So it's not a pretty story. Okay, so this RMRS actually stands for Rocky Mountain Research Station, and they've gone in every year in the Middle Fork and all of Idaho and surveyed the number of reds. These are, in fact, Russ flies in the helicopter and counts them. So here, this is the Middle Fork of the Salmon River. It's all in the Frank Church Wilderness area. There's no dams, there's no hatcheries, there's no harvest. Habitat's good to excellent. Here's the low year, 1995. These red dots were where fish were found in the entire basin. If some of you are familiar with the Middle Fork, you know, this is Big Creek, and then you have Loon Creek here. Loon Creek's this one, and Sulphur Creek. And then you get a big year, 2001, and you can see the difference. There's almost 1,800 reds versus 20, yeah, but they're clustered. That tells us where all the good spawning habitat is. So a mean of 771 reds. So if we look at resiliency, here's this graph again, going down. There's this little peak right here. I mentioned about 2001. That's these 3 years right here. We had some great steelhead and chinook fish in those 3 years. The reason we got these big returns is because we had more water, so the smolts are able to get down the river faster, and that was coupled with good ocean conditions where there was a lot of food in the ocean when they got down there. So everything lined up and they came back in spades. Okay, but it wasn't sustained, it dropped right back down. Now, if one of the hypotheses back in the 80s when they were really building a lot of the hatcheries for use, in the 90s up in Idaho, was that Idaho didn't have any fish because our habitat was underseeded. It didn't have enough adult fish in it. So one of the solutions was to use hatcheries to create more fish. So when more adult salmon return, if that were really true and it was underseeded, then you'd expect the bars all to stay up in this region here, if it's just simply there weren't enough fish there. But in fact, they do this. And what that tells us is that the problem is downstream and out of the basin. So it's not the fact we don't have enough habitat. We don't have enough fish getting back to the habitat. That's really the issue. And so here's one of the dams. I think this, I can't remember which one this is. Looks a bit like Bonneville and the spill. And this is Steve Pettit, longtime Idaho biologist, saying that the two things are the hydro system and the climate change, and they're going to really hit the fish. So what's been the history of the, when fish are endangered, they have to write recovery plans, and recovery plans have biological opinions, and opinions basically are a review of the actions the action agencies plan. They say, we're going to do this. Biological opinion says that's either going to hurt the fish or it's not. All 5 of the biological opinions that have been developed over the last 5 years by the federal government have been rejected by the courts. And they've been rejected because they're not scientifically sound. So as a result, salmon recovery has been being managed by the 9th District Court in Portland, which is probably not the situation we really want to be in. In 2014, the BIOP and Judge Simon told the Corps and Bureau of Rec they didn't follow the NEPA rules and they needed to prepare a comprehensive EIS, an environmental impact statement, to plan how they were going to recover the fish. It needed to evaluate a broad range of alternatives. It needed to break the decades-long cycle of court-invalidated biological opinions, and it must assess all reasonable and prudent alternatives for listed species recovery, including consideration of breaching or removal of one or more of the lower Snake River dams. Well, we just got the 2020 draft EIS in February. It was a huge disappointment to the environmental community. Yeah, the preferred alternative, which is the alternative they choose as for best for implementation, is essentially the status quo and spilling additional water. Some of the smolts get through the dams a little bit better when you spill. even though they acknowledged in the EIS that taking the 4 Snake River dams out was the best biological alternative for recovery. They didn't think it was economically feasible. But the preferred alternative will not recover Columbia Basin salmon and steelhead, and in fact, it actually dooms Idaho salmon and steelhead to extinction, given the SARs I've showed you. The spill is not going to make a difference, so they've kind of written them off. The EIS will certainly be challenged to go back into the court systems. It will almost certainly be rejected again as scientifically unsound. And after 5 attempts, do we have any faith that it'll go back to the feds and they'll produce something that's scientifically viable? It seems unlikely. So we're kind of between a rock and a hard spot right now. So why are we failing? We've spent 16, recent estimates are close to $17 billion on fish and wildlife restoration. All anadromous fish that come back to the Snake Basin are either extinct or at high risk of extinction. We actually had coho that came back to the Snake River Basin. They went extinct in 1986 to 89. So how do we rebuild Snake River salmon? Well, really simply, we have to figure out how to improve the SARs about 4-fold, get them from 0.7 to 1 up to 3.5 to 4. How do we do this? We have to address actions outside of the Snake River Basin. It's fine to spend money on habitat within the Snake Basin, and we have some degraded mining areas and things where it's appropriate to do so to make the habitat better, but that's not going to solve the problem. The problems are out-of-basin factors, and they are the ocean productivity, which fluctuates, the migration corridor through the Snake River and Columbia, where the hydro system is, and where the fish are moving through slackwater systems, often filled with largemouth, smallmouth, bass, and walleye. Through the estuary, which has been terribly degraded, although there's a lot of positive restoration work going on in the estuary, and then in the hydro system. The 3 with the red stars on them are the ones where we actually can make actions that matter, because we can't do much about the ocean. So to wrap this up, there's good news. It's actually feasible to recover Idaho salmon and steelhead. Like I said, a female Chinook lays 4,000 to 5,000 eggs. They are astonishingly fecund. We believe that historical SARs probably range from 6 to as much as 15%, probably the higher numbers in the rivers that are lower down in the system. Those are well above the recovery and rebuilding thresholds we talked about, if we can give the fish a chance. The troubling news is we have unique wild stocks and core wilderness habitat, such as the Middle Fork of the Salmon, that are presently at high risk of extinction. And they're showing the same trends as fish in other systems where hatchery and harvest impacts occur. Again, evidence that the impacts are out of basin. Within basin actions are not sufficient to recover them. Out of basin actions are essential to increase the SARs 4-fold. Current salmon populations and recovery goals are far below the reproductive potential. Russ has done some extensive work in the Middle Fork of the Salmon based on a couple of different historical sets of data that are independent from one another, both suggesting that instead of finding 1,800 reds in a good year in the Middle Fork of the Salmon, they ought to be finding 30 to 50,000 reds, maybe as many as 90,000 reds. So those systems are much more productive. Changing climate adds urgency. It's going to exacerbate water temperatures and so forth. And if restored, wild Idaho salmon and steelhead may be uniquely adapted to buffer against a changing climate. So that's the end of that rapid fire presentation, so that we'll have time for questions.
Rick, that was excellent presentation, and thanks so much. I know everybody's got a better understanding of this. I'm waiting to see if anybody else wants to put up some questions. I wrote down 2 or 3 that I had. Can you explain, those of us that follow this in the popular press, not so much in the scientific press, hear a lot about the relationship between the orcas and salmon and steelhead. Can you give us an overview of what that issue is?
That's a great question. You're talking about the southern resident killer whales that live off the Puget Sound, San Juan area. And that we had the female with the calf last year that was so caught so much attention because The female carried the dead calf around for a couple of weeks. Those fish or those mammals live in that area. They don't migrate very far. They run up and down the Pacific coast from essentially Northern California up into BC. And they're heavily reliant during about a 2-month period of the year on spring Chinook coming out of the Columbia River. And even if the other, there's been suggestions to use hatcheries to boost salmon numbers just to save the orcas. You know, it's been a little maddening for those who've been working on salmon recovery for 30 years and not getting a lot of traction with the larger public to see the traction the orcas got, but we're certainly willing to go along with the ride. But what they've discovered by watching the orca and really doing diet analysis is that they really won't turn to those other salmon species. They are almost wholly dependent on spring Chinook coming out of the Columbia Basin. And so unless the spring Chinook numbers can increase, we're probably going to continue to lose or see that killer whale population diminish.
Interesting. Got a question here from Vinnie Vincent in Wisconsin. Notice, Vinnie, that I did not say you were from Minnesota this time and incur your wrath. So Vinnie's from Wisconsin, and he asked the following question for you, Rick. With the main obstacle being the dams, how beneficial would it be to eliminate the hatcheries and let the wild fish thrive in the best way they can?
Ultimately, I think we're going to have to reduce our dependence on hatcheries, and we're going to have to reduce interactions between hatchery fish and wild fish in order to give wild fish a break. But if that does not occur in concert with removal of some of the dams, it seems unlikely to have a lot of benefit. It would have some benefit. It would be a very slow climb, and maybe not enough time. I don't know.
Dean Bates has a question for you, Rick. Can you speak to pinniped predation?
It can be significant, and it certainly has the feds and some of the tribal members wound up. We're talking about the sea lions essentially, and they particularly where migrating salmon and steelhead come into dams, or there's an example called Ballard Locks up on Lake Washington, where there's a small steelhead run there that concentrates into a very small physical area to transit that locks to get to their spawning stream. The sea lions figured out, and they were able to just decimate that population. So the feds have actually started removing the seals, which doesn't, as you can imagine, comes with its own set of controversies. So it's an impact, but it's an impact because of the locks and the fish ladders that have concentrated the fish. Yep.
Rick, I got a combination question here. Part of it comes from Tom Logan and part of it comes from Dennis O'Brien here in Michigan. How does FFI play into these resource issues? Are we effective? And is it possible for FFI to make a difference for the resources and our members? And Dennis asks, kind of in a related issue, what can we do as individual anglers to help out with this issue?
Well, let's tackle the first part of it. So FFI's roots are in conservation. That's why we were originally founded, to try to be a stronger conservation voice, even though we spend a lot of our time casting fly lines and tying flies and socializing and going on fishing trips. The root of our organization was to be stronger, more organized conservation advocates, and we are that. That said, we have a small volunteer force, a small staff. We do a huge amount of work and increase our impact by partnering. And in the case of Pacific Coast and Pacific Northwest salmon and steelhead issues, we partner with a whole cohort of like-minded groups, most of whom are over in Oregon and Washington, like the Native Fish Society, the Conservation Angler, the Wild Fish Conservancy, Earth Justice, Sierra Club, and so forth. And we have, and then we have our steelhead journal, the Osprey, that we were the sole kind of managers and proprietors for a number of years. Recently, we've expanded that. Again, the Conservation Angler and the Wild Fish Conservancy and the Native Fish Society are all part of that group now. We still publish the Osprey. Articles get out. If anybody on the call doesn't know about that, get hold of the office. We can hook you up with the Osprey. And a lot of great articles and journals. But we're very active on all these issues through this Earth Justice and Sierra Club link. We have a coalition of people like myself, Howard Schaller and Margaret Filardo that I mentioned earlier, Tom Stewart with Idaho Rivers United, and we meet and talk regularly and respond a lot through the court. And it's cost FFI very, very little money over decades now. They want us as part of the coalition to broaden the voice and broaden the diversity of the group that are making these legal challenges. The Sierra Club and Earth Justice pick up most of the dollars. As anglers, I think we just get more informed. A great article I just forwarded to both Dave and Tom was in the Harper's magazine last November on the Columbia River. If anybody wants it, you can reach out to Dave or me or Tom. We all can send you the link to it. Phenomenal article, really well written, probably about as uplifting as my talk was. So, but tough duty. So I think be informed, get involved. That's about all we can do as anglers.
Great. Thanks, Rick. Bruce Williams has a question for you. Of the 8 dams that affect the Snake River, how many have marginal economic benefit? That's an excellent question.
That's a great question, because the 4 on the Columbia are big dams, and the ones like Bonneville and John Day in particular, and then Grand Coulee, of course, which is a stop. I mean, fish can't get past Grand Coulee. Those are the big generators and economic drivers in the region. The 4 lower Snake River dams are in a canyon, and they're low dams, what we call run-of-the-river dams. They don't offer any real flood control. They generate an average of 2 to 5% of the total electricity comes out of the whole Columbia River federal system. So not very much, and they don't offer a lot of irrigation because they're down in a canyon, and all the agriculture is up on the tablelands above it, so the water's pumped up. So I think the biggest driver for them economically is this concept that Lewiston, Idaho is now a seaport, because one can get in a barge and go all the way from Portland to Lewiston, Idaho. Most of us in Idaho who aren't involved in the grain shipping industry or wood shipping industry think it's a ludicrous concept. And the Salmon and Steelhead have paid a huge price for being able to run small barges up the Snake River. So a lot of the economic driver there is the huge grain exports coming out of the Palouse area, and the wood chips and things coming out of the central Idaho forestry, which of course we all know that forestry has declined as well. So a lot of that has shifted over just through economic drivers to rail and truck. And there's some discussion now about all of these are subsidized. So we have to really look at where the money's going. Could we shift the subsidies around? We don't want the wheat farmers or the forestry people in Idaho. We don't want anybody to take a huge hit. The salmon steelhead already are. So are there ways to shift subsidies around to keep people whole and yet make the river more free and give the fish a chance? I think the answer to that is yes, if we can get people to the table.
Rick, this is a question I have, and the way we've intervened on some dams in Michigan is, are any of these dams up for relicensing very soon, where you could stick your fingers into the relicensing process and get FERC to take some action on these?
No, unfortunately not on the main stem dams, because it is happening on the smaller tributary dams. That's exactly what happened on the White Salmon and the Condit Dam. It's what happened up on the Glines and the Elwha Dam and the Elwha Peninsula. Those come up for relicensing. They're aging structures. There are higher environmental standards, the cost. This is a lot of what's happening on the Klamath as well. The cost of retrofitting those dams to make them meet current environmental conditions that are required exceed anything that they would be able to generate. And so the companies that own them are making the decisions to take them out. Unfortunately, on the Elwha, which was an extraordinary example, because we had this 100-mile long river, 85 miles of it was stopped by these dams. We had remnant populations coming back to the lower river of all 5 Pacific salmon species. We had lamprey, bull trout, coastal cutthroat, and the steelhead had been locked above the dam. It turned into this magnificent and storied rainbow trout fishery because they were steelhead that were now landlocked above the dam. So they took those dams out, it would have been the best possible natural experiment we could have ever designed. But they went in and put hatcheries in on about 5 of those different species. We've managed so far, FFI being part of that, to keep them from putting a summer steelhead hatchery in there. And the fish numbers are rebounding much quicker than anyone expected. And this has usually been the story. There haven't been a lot of examples of dams taken out in the West, but they're taking a bunch out on Atlantic salmon and New England rivers. And in every instant, the expectations for the way the ecosystem would recover and the way fish would move back up into the system have exceeded what anyone thought would happen. But lessons to be learned if we can learn them.
Rick, we have 3 questions left here.
Sure.
William Evanson asks, how much difference would removal of a single dam make? How many dams need to be targeted to have a chance for this recovery to occur?
It's a great question from Bill. I should tell everybody, Bill was my doctoral advisor. He's a great guy.
Oh, okay. He's getting even with you. Yeah.
Yeah. So we go back a long ways. And it's a great question. It looks like if you do really simple math on the SARs, that there's about 3/4 of an SAR to 1% SAR loss at every dam. I mean, it's gross oversimplification, but so if you take, we need to get that, we need to increase Idaho SARs fish by 4. If we took 1 out, then you're going to get, they're at 0.7 to 1 right now. You get to 1.5 to possibly 2. So I think to actually make a difference for the Idaho fish, you're going to have to probably pull at least 3 of the Snake River dams out. There were some studies done by Battelle back in the 80s that suggested that the habitat behind each of the 4 Snake River dams was not exactly equal. And that if you were going to take 1 out, I think Little Goose was the one they recommended to give you the most habitat back. That would mostly benefit fall Chinook. We were talking about steelhead and spring Chinook, who are not main stem river spawners. They're going through and then traveling well beyond Lower Granite Dam and Lewiston up into the higher elevation. So for those species, it's really a passage and mortality associated with a hydro project. The fall Chinook would recover because it would actually reopen some of their natal spawning habitat to them. But the fall Chinook are the least desirable of the both sport and recreational commercial fisheries. The spring Chinook and steelhead are more valuable.
This question comes from Phil Parker, who is one of my fishing buddies, lives in Oregon right now. And he says, to what extent is dam removal a legal versus political issue? Are there special interest groups opposed to the dam removals? And what's the real likelihood any of them will really be removed?
Well, that is kind of the $64 million question. Yeah, absolutely. It's highly political. we have been told for a long time that taking any of the liver snake dams out would require congressional approval. And that's kind of the common wisdom. I've also seen counter arguments that that's not necessarily true. And while the Oregon governor has stood up and recommended the removal of the lower Snake River dams, the Washington governor has been demanding studies to try to inform that and is leaning that way. Idaho Representative Mike Simpson has made a very strong statement about a year ago that he would do everything he could to make sure Idaho salmon and steelhead didn't go extinct, up to and including taking the dams out. So he's not advocating it yet. And Governor Brad Little for Idaho has convened a salmon work panel, but they were kind of told to figure out an answer but not take the dams out, which is of course what the feds have been trying to do for 25 years, and you can't get there. You can't get there from there. So that's an example of how politicized the process is and can be.
Yeah, this another question.
NGOs are a really important voice, and a lot of my salmon science colleagues, we've kind of stopped, now that we're in our retirement years, we kind of stopped writing scientific papers, and we're writing more white papers and trying to get information out to the public to try to create a groundswell of public indignation and information. because that will have more, appears to have more possible effect on politicians and government leaders than any of the science we do. So, and we have long careers where we've done all that science already. Biologists have been telling very clearly, including our group, 30 years ago or more, what the solution was, but it hasn't been acted on.
Interesting. Here's another question, and kind of in the politics, money area. Money usually talks. How much in recreational fishing, jobs, et cetera, does this area produce compared to what the region stands to lose? And is this enough to make a difference in changing the attitudes of the public, the legislature, regulatory agencies, et cetera?
Well, I'm sure most of you have looked at economic studies, you know, and it seems they can tell about any story that people want them to, and they're criticized that way. That said, there have been some independent economic studies of the value of the salmon and steelhead fisheries in Idaho, and they're in the billions of dollars. If you look at Idaho, in our big wilderness area there, in our local economies, it's agriculture, it's forestry, it's mining, and then you get down to Boise and it's kind of high tech. And we know that the forestry, you know, our life cycle on our tree systems here in Idaho about 200 years, as opposed to about 40 to 80 over in the coast in the wet temperate forests. So our long-term rotations here are not very productive. So forestry has really slowed down in Idaho. It's still there in the background, but it's not a major driver anymore. We have grazing, but we all know that people becoming increasingly critical of the impacts on the landscape that's causing. And then mining, and that also because of pollution and sediment concerns is also being curtailed a bit. So what's left for these small river communities scattered all through central Idaho that all occur along these big river systems? What's the renewable resource for them? It's the fish. It's the fish and recreation. It's fishing, whitewater rafting, camping, tourism, recreation. The fish play into that in spades. So that's actually one of the best things we could do for the small communities in Idaho that used to be mining and forestry driven, is to rebound these salmon and steelhead populations.
Interesting. Rick, I think this is our final question of the evening. Again, from Vinnie Vincent. At some point, the dams will cost more to maintain than the revenue produced. Are any of the dams close to that stage in their so-called useful lifespan?
Another great question. They do have, dams have life cycles too. And many of them, particularly I think the canyon ones, the Snake River Canyon ones, they're low run of the river ones. They fill with sediment, they hold less water, they become less productive, the concrete ages. I believe that many of the lower snake dams are slated for turbine replacement within the next 20 years. And I'm better with concepts than numbers. So I always have a hard time remembering the numbers, but each of the dams has between, I think about 4 turbines in it. And each turbine costs millions and millions of dollars. So the numbers are astronomical to replace just the turbines in the Snake River dams over the next 20 years. And so it's a great question, but most people aren't looking at it.
Well, Rick, I think that brings us to the end of our questions. I want to thank you for just an outstanding presentation tonight. I think you've given all of us a much greater understanding of this issue and hopefully created some advocates that we didn't have before on this issue.
Dave, we have a relatively small group. Can we put the video on for everybody? We can do a little wave at everybody and see some faces we know. Is that possible?
I don't know how to do that.
Okay. So,
I'm not sure we can turn them on in a webinar.
Okay. Well, I'm not available to figure out how to do that either, but a lot of friends out there and people are here. Thank you for your interest. This is a really exciting and important and continually frustrating area for a lot of us to work on, because we feel so tied to the rivers and tied to the fish, to what they are and also what they represent. They represent, I started my career, and nobody knows this better than Dr. Evanson. I started my career working on falcons. I was really interested I did my master's work on prairie falcons. And I was a falconer for a little while. And there was, when I had a bird on my arm, they were so wild and so incredible. And I get that exact same feeling when I've caught a wild steelhead and I'm standing in a river holding it, letting it revive and watching it swim away. These are, and just imagining the places that that animal has been through its life that I will never see and never know. And just because of who they, the type of animal they are, how they experience the world so differently than we do. And I kind of wish I could have that experience and know what they have seen and done. And I think we owe them some responsibility and a legacy to take care of them and allow them to continue to be the wild creatures they are, and how they inspire us. And so this has been both passionate and frustrating for a long time. I appreciate everyone's staying in.
Well, all we can do is thank you for your work, Rick, and hope that you can inspire new generations of scientists and advocates to step forward and keep up the fight, because it certainly doesn't look like there's any immediate solutions to this problem that are going to become evident.
Well, I'll tell everybody one quick short story. I got contacted here a few months ago by a group of high school students here in Eagle, and they were doing a video senior project on the Snake River dams in Idaho steelhead. And these young men, about 6 of them, came over. We did a videotape session. They did one with Russ Thoreau, my co-author, I think likely to be our Leopold Award winner for this year because of his work, and a lot of other luminaries in the salmon world. And these young men are passionate fishermen. They're sending me photos. They care about the resource. This is the demographic that FFI is trying to figure out how to connect with. And these kids gave me hope for the future. Were really something really special. And they showed up to interview me, video interview me. They had 2.5 pages of typed out questions to ask me.
Wow.
They were ready. It was great.
That's very cool.
Thanks, Dave. Thank you, everyone.
Well, thanks, Rick. I know our audience enjoyed this tonight, and I hope you'll all spread the word on our conservation conversations and help FFI protect all fish in all waters. Our next webinar is June 2nd. If you join us then, you're going to meet Jason Ulseth of the Chattahoochee Riverkeeper to learn more about the conservation of the Chattahoochee River in Georgia. Check out the other webinars that we're offering. They're on fly tying, casting, our Learning Center, and Jeff Courier's Global Fishing Adventures. Finally, if you're not a member of FFI, please consider joining our 12,000 other members in supporting these webinars and the conservation work of FFI. The only way we're going to be able to make a bigger impact in conservation is to speak for more people. Otherwise, we can't be a significant player and be relevant in the conservation world if we don't increase our membership. And so we need you to go out and join that for us. With that, we want to thank you for joining us again. Stay safe and have a good evening, and get out there and go fishing and release those fish carefully. And maybe there'll be another steelhead coming back to Rick's River in the next year or so. So again, thank you.
Thanks, Dave. Thanks, everyone. Bye-bye.
Thanks again, Rick. It was great.
You bet. Thanks, Dave. Bye-bye.
Bye-bye.